Good morning, everyone. Are you able to see my screen? Awesome. So thank you so much for having us. And we are very excited to share with you today some insights on reshaping the road construction industry, specifically looking at management and technology solutions. So it is no new news that the road construction industry, just like other sectors of the broader construction industry, has been suffering for decades from low productivity, scheduling cost overruns, unsafe job sites, fragmentation, volatility, and other chronic problems. And while the road construction industry has been making effort to challenge its daunting past, it has been recently shaken by the unwelcome, uninvited guest, the COVID-19 pandemic. And just like other industries, the COVID-19 outbreak had a significant impact on this industry. However, although a crisis, the COVID-19 pandemic can also be seen as a wake-up call for the industry, as it has brought to the surface long-standing problems and highlighted areas in urgent needs of improvement and reform. And now the question moving forward is, well, how to thrive in a volatile, uncertain, complex, and ambiguous environment. And to answer this question, we look at an industry that has always been a source of innovation in construction, and that is manufacturing. The significant productivity gap between manufacturing and construction has been highlighted for decades with many researchers, and two major reasons were identified for this poor performance in our industry: the inadequacy of traditional project management theory and the improper applications of technology. So today's talk, we are going to cover some solutions to address these two major issues. On the management side, we are going to introduce lean construction. And on the technology side, and from the wide array of technologies that have been gaining momentum with what we call Construction 4.0, we are going to highlight three main technologies: 3D modeling, augmented reality, and sensing and wireless technologies. And before I move on, just wanted to note here that each of these topics could be covered in its own session. So we kind of decided to adopt a breadth versus depth approach so that we can shed light onto multiple aspects of these topics. With that said, let us begin with lean construction, starting with an overview of the lean construction journey. So this notion of the innovative management theory originated in Japan in the 1950s with what we call the Toyota Production System, or TPS. And TPS is a new management philosophy for manufacturing. And then the term lean was first coined in 1988 as a way to distinguish between what is improvement versus what is mass production in manufacturing. And then the term lean productivity or lean production was conceived in the 1990s and was defined as a 5-step process that starts with specifying value, identifying the value stream, making value flow, let the customer pull value, to finally pursuing perfection. So these are the 5 steps of lean production. Now, influenced by the gains that were achieved in manufacturing through lean production, the potential of lean in construction was introduced in 1992. And in 1997, the Lean Construction Institute was formed. Now, once the Lean Construction Institute was formed, we had more context onto lean construction. And so they defined lean construction as a culture of respect and continuous improvement aimed at creating more value for the customer while identifying and eliminating waste. And two things worth highlighting in this definition are value and waste. What is value? Value is defined by the customer. And the customer could be internal or external. The end user, for example, can be a customer. The state DOT can be the customer. The contractor can be the customer of the designer, and so on. Understanding who the customer is, what the customer values is critical to implementing lean. Now, if an activity is not a value-adding activity, we call it non-value-adding. And there are two types of non-value-adding activities. We've got non-value-adding activities, but necessary, and these are required. We cannot remove them. And we have non-value-adding activities that are pure waste. And these are the ones that we want to eliminate. And then when we talk about waste, another question follows is, well, what is waste? How do we see waste? How do we learn that something is waste? Through research, 8 types of waste were identified. And these 8 types are found in every industry, including the road construction industry. And these include defects, meaning mistakes which require rectification, overproduction, producing items that no one really wants, and we end up having inventory. Waiting, meaning having processing steps that are not actually needed. Wasting time, non-utilized talent, meaning having skills, having talents that are not being recognized. Transportation, meaning transport of goods from one place to another without any purpose, which also results in wasting time as well as in wasting resources. Inventory, and when we talk about inventory, we talk about having stocks of raw materials, work in progress, and finished goods. Motion, useless motion of people, workers on the job site, even in the office. Extra processing or over processing, meaning producing too much of the product that no one really needs, and we also end up having other types of waste. Now, these 8 types of waste, we have an easy way to remember them, and that is downtime. So each letter of downtime represents a type of waste, and that's an easy way to remember defect, overproduction, waiting, non-utilized talent, transportation, inventory, motion, and extra processing. Now, with lean construction, kind of going back to the definition, lean construction aims to eliminate non-value adding pure waste activities. And if we look at this picture right here, we can see that in construction, the majority of activities are non-value adding pure waste. And if we are able to remove these wasted activities, we can increase value. So through lean construction, we want to eliminate this red portion right here, these non-value adding activities that are pure waste. We want to minimize non-value adding activities that are necessary. And it's important to note here that we cannot really eliminate those non-value adding activities that are required. And we also, at the same time, we want to optimize value adding activities. So these 3 components are essential to lean construction. And in order to do that, we need to understand what lean construction is. And one way to think about lean construction is to consider these 3 essential elements: culture, principles, and practices and tools. While practices and tools are important to implement lean construction and are probably a more tangible way to experience lean construction, they are not sufficient if we don't have the right culture and if we don't understand the lean principles. So we're going to start with looking at lean culture. When we talk about a lean culture, we say it is a culture built on accountability of all stakeholders. We consider the project throughout the life cycle, the supply chain. Everyone involved in the project has to be accountable to their actions. We talk about reliable promises between participants. It's fine to say no, but if you say yes, you have to actually do what you said you're going to do. So making reliable promises is important for a lean culture. Communication, transparency between participants, having a mindset of continuous improvement, always realizing that there is room for improvement, empowerment of people, flexibility and resilience, leadership, motivation, respect of people, trust between people, and having good teamwork and high performance teams. Now, this lean culture is supported by a series of lean principles. And these principles are what distinguish lean construction management from traditional project management that we're used to. These principles include focusing on long-term thinking versus short-term. In traditional project management, we often really focus on the short-term gains, and we don't really consider long-term viability. Creating continuous flow and eliminating waste, kind of going back to what we introduced earlier, waste is important. Embracing a pull system instead of a push system like what we have in traditional project management. Typically, in traditional project management, we push work onto the workers in the field or onto the next person in line. We don't ask them, what's your capacity? And this is work according to your capacity. So in Lean, we use pull system. We pull as much as they need instead of push. Leveling and balancing workload. It's important to have a balanced workload across all the trades, across all the people involved in the project. Standardizing processes. When you standardize processes, you start reducing errors. Building in quality. If we are able to build quality into what we do, we don't really have to do those multiple check-in inspections. Leveraging virtual or visual management, making things visuals on the project so that it makes it easy for everyone to understand the process, understand the plan, understand the task, understand what they need to do. Integrating technology to support people and processes instead of eliminating the job of some people. Growing leaders, developing teams, establishing a process for continuous learning and improvement, and that is critical. And we can do that through deep observations and iterative learning. And finally, focusing on incremental improvements instead of radical changes in order to achieve great gains. So these are some sets of principles that are important to know about and consider when we talk about Lean construction. Now, these principles are manifested into or through numerous Lean practices and tools. To name a few here, we have value stream mapping. 5 S's stands for sort, set, shine, standardize, and sustain. We have the 5 whys, and this is a technique used to conduct root cause analysis. We have what we call obeya. Obeya is a Japanese term for big room. It's a big room where all the stakeholders are brought in, and it is used to inform better decisions. Pull scheduling and planning. Again, instead of pushing work, we bring people who are involved in their tasks to let us know how much they can perform. Last planner system. The last planner system is an entire structure where the last planners, and we mean by last planners, we mean foreman, superintendent, the people who actually do the work. So we bring those people early on in the process, in the planning phase of the project, and we engage them in the planning process, something that does not happen in traditional project management. Choosing by advantages, or CBA. CBA is considered to be a robust, objective decision-making system. We've got target value design, as opposed to traditional competitive pricing used in hard bids. Just-in-time delivery of materials. And that is important also for documents, not just for materials, for documents and information. And then last on the list here, I have integrated project delivery, and this is by far the most innovative delivery system in construction. And it is built on trust, collaboration, and transparency between stakeholders, as opposed to what we traditionally do in design but build or hard bid projects. Now, 2 practices that I would like to highlight here are value stream mapping and 5 S's. Starting with value stream mapping, a value stream map can be defined as a visual representation of the material and information flow of a process. So we take a certain process and then we walk through the entire process from A to Z. And we identify the people involved, we identify the activities, the steps, and we focus on the flow of materials and the flow of information. This value stream mapping technique can be used or can be seen as a communication tool for all process participants. It can be also considered a business planning tool to strategically plan changes that are needed to the current process. We can also say that it is a tool to manage changes that we make to the existing process. So in a nutshell, the value stream mapping provides us with a common language to talk about a certain process and identify areas of improvement. Now, the value stream map can be developed for the bid selection process, for estimation, for material management, procurement, field installation, inspection, and other processes in road construction. So it doesn't really have to be just in the field, but we can consider the entire life cycle of the project. And then we can take a certain process and do the value stream map for that specific process in order to identify areas in need of improvement. If you want to kind of detail more this value stream mapping technique, we talk about 5 steps. We start by identifying the customer and what they value. We then map the current state of the process. And the purpose of this step is to provide the base level for the process. And it is also the first step to help us learn to see waste. So it's not until we map the current process that we start seeing waste. And then the current state map is also built by walking and drawing the processing steps of a certain process. So we typically have a person deployed in the field or on that process, and they start drawing all the steps and the flow of materials and information of that process. Once we have the current state map, we then begin identifying what is value, what is waste, and what is non-value adding but required. So we look back at that chart that we have, we see how much waste we have, how much value we have, and we start looking into ways to eliminate waste and increase value. And the process to do that is we can use other lean tools and practices to help us eliminate certain waste that we identify. It is also important to note here that all the improvements that we identify or that we choose to make have to be realistic and have to be feasible and have to be achievable. So once we're done through step 3 here, then we create a future state of the process. And this future state is going to represent improvements that need to happen and will happen. And then we begin the implementation of the future state so that the future state becomes the new current state. Now, I'll just conclude the value stream mapping with saying that value stream mapping is just a tool because without the right culture for implementation, it is worthless. So kind of going back, we have a tool, we have a practice, but if we don't have the right culture, we don't really get the benefits of this practice. The other lean practice here that I have on this slide is the 5 S's. And here the first S stands for sort, eliminate whatever is not needed by separating needed tools, parts, information, instructions from unneeded materials. The second S is for set in order. We organize, we arrange items daily so that they are easy to access and easy to use. The third S is for shine, meaning we clean the work area daily, making sure everything is visible. The fourth S is for standardize, and this is where we create a process that reinforces the previous steps. So we build standardization into sorting, setting in order, and shining. And last but not least, sustain, and this is by far the most difficult step. Sustain is all about creating a culture to implement the 5 S's. So all these 5 steps, they look easy to implement, but if we don't really have that right culture, it becomes difficult to sustain these improvements on the project. An example of a 5 S's implementation on a highway project is shown here, where we're seeing maybe a typical storage room. That's how maybe a typical warehouse, typical storage room, or a typical even laydown area looks like on a construction project. And we can see that finding tools or finding parts can be difficult and can be time consuming. If we take this storage area and we apply the 5 S's, we get something similar to this. And we can see now that everything is organized, everything is labeled. So when a person comes into the storage room, they can easily identify what they need, and that is going to result in time savings as well as less defects, and most importantly, increased morale of the people involved in this process. And although this looks simple to do, but again, maintaining this, so it has to look this way every day throughout the project duration, and that's not easy. And that's why kind of going back to having the right culture, having the right mindset is important. And this example concludes the discussion on lane construction. And I'll now shift gears and introduce some technologies. And I'll start off with 3D modeling. And I will refer to an active NCHRP synthesis project 5214 on 3D digital models as highway construction contract documents that I've worked on with my colleagues at the University of Kentucky, as well as the Kentucky Transportation Center, where we surveyed 41 state DOTs regarding their 3D modeling practices. And if we take those 41 state DOTs, 15 noted that they do not use 3D models. 21 said that they are using 3D models for information purposes only, meaning that state DOTs provide contractors with models for reference only and are not part of the legal document. And 5 state DOTs said that they are using 3D models as part of the contract document. These stats here, they show us that more state DOTs have been investing in 3D modeling and sharing 3D models with contractors. They also indicate that we have a trend to move away from paper-based documentation to enable digital project delivery. And this transformation to shift to digital project delivery is evident in the road construction industry, where if we look at this graph right here, according to the survey findings, we can see that most states that provide contractors with 3D models for information purposes only, they do that on new road construction projects, on corridor widening and intersection improvement. And we also have some states that also provide models for road rehabilitation as well as road resurfacing. And similar trends are also detected in the state DOTs that also provide models as contract documents. And these findings show us that the requirements for 3D modelings are increasing in the road construction industry, and state DOTs as well as consultants and contractors are recognizing the benefits of modeling. Some of these benefits can include easier calculation of construction quantities, easier identification of planned conflicts, improved communication, fewer project delays, more cost savings, and most importantly, improved accuracy and documentation. Now, embracing 3D modeling in road construction enables other innovative technologies that are part of Construction 4.0 to be integrated. And one such technology is augmented reality. AR can be defined as an information aggregator and a data publishing platform that allows the user to do one of the following things: passively view displayed information, actively engage with and interact with published content, and collaborate with others in real time from remote locations. So according to FHWA, in road construction, augmented reality can, or the user can display content related to what is not constructed, what was intended to be constructed, what is hidden from view, and abstract information that is aligned with the real world. the user can experience augmented reality through a headset or a head-mounted device, such as the Microsoft HoloLens. So the Microsoft HoloLens is a headset. It is a software and a hardware on its own, just like its own computer, where the user puts the headset on their head and they can see virtual content overlaid onto the real world through the glasses. The user can also experience augmented reality through handheld devices, and that could be either through the phone or an iPad or a tablet. So in this left picture here, we can see the user pointing their cell phone at the 2D plan and seeing the 3D model of the plan. So that's an augmented reality. So we've got the 3D model virtually augmented onto the 2D plan of the building or of the project. And in the picture here on the right, we can see the user through their tablet looking or visualizing, displaying the underground utilities. So that's also another way of seeing hidden information through augmented reality. Now, each of these two types of displays, they have their pros and cons, but the handheld devices right now might be a more feasible option for state DOTs, because many have already invested in providing their or equipping their field workers with iPads, so they do have access to that technology. And also the head-mounted display devices still need to be improved and further developed in order to make them ready for use in construction. Now, as this technology is maturing, we can already see some capabilities for augmented reality. And typically, we look at these capabilities from these 9 aspects. So we look at analytical automation, meaning reducing the human aspect of a process, disintermediating or removing steps from a process, geographical, allowing people to connect across distances, informational, integrative, intellectual, sequential, and tracking. So these 9 capabilities of augmented reality are important to be aware of because they help us understand how the technology can help us improve a certain process or help us implement a certain use case in the industry. One of the use cases that I'd like to share with you today is the on-site navigation for, or the AR, on-site navigation for excavator driver. And this application was developed by my colleagues in Austria, where we've got 2 technologies. We've got the augmented reality and we've got GPS, global positioning systems. So these 2 technologies were integrated together to develop a system that allows operators to navigate to their next target on the job site and access information they need to complete their task. So we can see here that these yellow tags, these are augmented visuals or displays onto the real world that allows the operator to guide them or to kind of get to their next target on the job site. This tool or this kind of use case is also important to identify excavation areas, identify how much earthwork has been removed, and other applications on the job site. So by enabling the operators to augment their real world vision with virtual information, they can actually become more efficient at their tasks. Now, this particular use case, if we are to think about it more from how it was developed and what it can achieve, we can say that this use case demonstrates 4 AR capabilities, and these are automation, geographical, informational, and sequential. So if we are to think about the use case, we can think in terms of these 4 capabilities. And then this use case was actually implemented on a real project, and the following benefits were observed: enhanced decision-making, enhanced spatial cognition, and improved productivity, quality, and safety. So just from one use case that is a simple use case, we can start realizing benefits on the construction projects. Other AR use cases that are also showing potential in road construction include using AR for inspection, enabling the vision of inspectors with documents, with information, with 3D elements, so that they can do their inspection more efficiently and effectively. Doing AR training. Right now, we are losing a lot of the workforce. So kind of capturing the skills and knowledge of the senior workforce and providing AR-enabled training to the younger workforce can also be an AR use case. And then doing AR for quality assurance. We can overlay the 3D model onto the existing installed work in the field so that we can depict any discrepancies and conflicts between the two digital and physical assets. With that, I'm going to hand it over to Gabe to talk more about sensing and wireless technologies. And Gabe, just cue me and I'll advance the slides for you.
It would help if I unmuted myself.
I was getting ready to say it, but you're so smart, Gabe. You got this.
It's moving a little slow after watching another loss to Duke last night, but we won't talk too much about that. So thank you, Hala. It's a great coverage of I think some important innovations in not only management theory, but also in different emerging technologies. So I'm going to talk a little bit about an active research project here that's, again, from the National Cooperative Highway Research Program. It's project 03140. It's a 2.5-year project. You see our team here at the University of Kentucky is leading the effort, but we have excellent partners at Iowa State University, Colorado State University, and HDR Engineering. And what this project is seeking to do is to identify and draft guidelines on how we use a variety of technologies in construction and asset management for highway projects. And the idea with that is, I know in my personal life, like we just are flooded with a variety of different technologies that we can use. Whether it's a wearable technology, whether it's something within the smart homes, things like that. And that's just, it's overwhelming. And I'm guessing in your all's line of work that there's vendor offerings of technologies that come to tell you that this is the new, nice, shiny thing that's going to solve all your world's problems. And it's the same thing with DOTs in highway construction and asset management. So what they asked us to do is to take a step back and identify guidance that we can draft so that they can implement these technologies effectively. They identified 10 projects, and they being panel members for NCHRP, which are representatives of different DOTs. So the 10 technologies we're looking at are on the slide there, some of which have been around a while. You know, GPS is something that we've had certainly on our cell phones for quite some time now. Others are new and emerging. Things like object recognition technologies and e-ticketing technologies are relatively new. And so it's this mixed bag of different technologies that have been around, that are new, but DOTs just feel like they're not able to fully take advantage of their application potentials. And so that's what we're doing over this 2.5-year project. So if you go to the next slide, thank you, Hala. We've captured a lot of data to this point and have interviewed several DOTs. And so the slide you see here presents the results of one of our surveys that was one of the questions of a survey that we conducted, where we asked in particular for new construction of roadways or expansion of roadways, how are you using these technologies? And we sent this out to 2 different AASHTO committees, one that's targeted for construction personnel at DOT and the other one for asset management. And so this would have gone out to a potential I guess, a net of about 100 people. So one representative for each DOT, one in construction, one in asset management. So you see the results there with the N value, the sample size that we captured. And so there wasn't a huge number of users of any particular technology, but I think what you can grab from the sample size there is similar to what I've mentioned at the beginning. So object recognition, infrared are two kind of new and emerging. Very few DOTs said that they use them. GPS, GIS, and even kind of new technologies like UAS and e-ticketing have some use there. You see the breakdown between rural and urban, or if they use it on both. So these are technologies that often show up as valuable to both rural roads and urban routes as well. And then the other graph is the same information, but for rehabilitation or resurfacing projects. So kind of more maintenance or smaller overall project cost and durations, but you still see a mixture of both rural and urban. The three that are highlighted there in yellow, GPR, object recognition, and infrared, I'll talk a little bit more about those here on the next slide. So we'll start with object recognition. I mentioned this project. What we're trying to do is identify guidance. And so, and guidance on how we implement these technologies successfully. And so when we think about a DOT and how they can successfully use technologies, the implementation factors that we identified fell into 6 categories there you see underlined in the primary bullets. So things like how the DOT is structured. You have personnel groups that are responsible for using the technologies, the IT infrastructure, the security of the data that you capture, what policies and procedures within the workflows might need to change for the technology, what training might need to be out there, how you engage stakeholders to effectively support the use of technology, and then kind of a catch-all category of, tell us your feedback from their use and other considerations. So for object recognition in particular, we interviewed several people from both the Iowa DOT and the Utah DOT, as well as had Trimble, which is a technology service provider to many different aspects of roadway design, construction, and asset management, asked them for their input on this as well. So with a technology like object recognition, it's new and innovative for the applications here for roadway projects. And so in particular, Iowa and Utah had used the technology review groups, or something generic, which is made up of end users from different divisions of the DOT to do a good job of evaluating the potential for the technology before you just throw it out there and hope that things work. So that's the idea with those. And so that was something that was successful with object recognition. Since it's new, there's not a lot of in-house expertise related to object recognition technology. So that's something that a third-party vendor will often provide. Security is also sort of driven by the third-party vendors through the use of like multi-factor authentication and firewalls. So we can limit who has access and kind of guarantee the individual accessing the data is the one behind their screen there. Object recognition is often used to kind of integrate with asset management workflows, so we can automatically identify a particular guardrail and its condition, different assets, and so that's how that technology integrates into how the DOT operates. Training is often provided from the vendors because, again, it's still so new. Pilots and outreach help with engaging stakeholders, and it's still emerging, but there's a lot of potential here. So a use case that we see over in the blue box from Iowa DOT, they wanted to use it to automatically identify trucks leaving a plant and when they arrive on the job site. So it's a visual verification of this data. Like many DOTs, Iowa is dealing with a limited workforce. So they may not be able to staff every single project with an inspector at all times. And so what this technology allows them to do is through a stationary camera setup, be able to visually verify when the material shows up onto the project so that the DOT can verify that they're getting the material that they're paying for. So if we go to the next one, yes, thanks, Hala. So infrared, kind of walking through the same ideas here. So support for funds is critical for infrared technologies because there is some hardware investments that need to happen. A lot of them are still driven by vendor support. And so they have proprietary software that will use to visualize and analyze the data. But once you bring that over into the DOT, you got to figure out a way to store all that information that you capture. The infrared data is often shared with contractors and equipment operators, depending on use case. And so there are some concerns there with sharing information, but there's not often data standards with the infrared data that is captured. There are some documented procedures, Wisconsin and Alabama in particular. I'll talk about Alabama's here in a little bit. Training is focused primarily on the hardware. The data that you get is kind of intuitive somewhat, but FLIR is a provider for many infrared technologies, and they offer certifications for users, so training and certifications there. And then since the data is shared with external stakeholders and engages several external stakeholders through the DOT, having buy-in and validation to demonstrate a proof of concept is important. Technology is kind of time of day, weather conditions, surface conditions can play a role into the quality of the data that you get. So the picture there, the kind of red heat map, is the output for a paver mounted thermal profiler. So this is a thermal imaging technology that's mounted on the back of an asphalt paver. So traditionally, you might have a infrared gun where you might shoot temperatures that are just spot points around the mat behind the paver. What this does is it automatically scans back and forth as the paver moves along the mat there and gets temperatures. And so that temperature being a critical component to the quality of the asphalt mat for the DOT, and so they can identify where there might be cold spots and things like that that are of concern. The way Alabama used it, the kind of breakdown there in the blue box on the right, ALDOT, they have a standard procedure for how they evaluate remixing equipment. So a material transfer vehicle or a remixing device, so something between the asphalt truck and the paver that keeps the material moving. What they did was they used infrared technology to make sure that equipment is keeping the asphalt mix hot as it's specified. And so they will verify and approve certain remixing devices based on whether or not they meet that specification. And then the last one I'll talk about is ground penetrating radar, or GPR. This is also a relatively new and expensive technology to DOTs. It's an advanced subsurface mapping technology. And so this is a great way. Hala did had a picture there of augmented reality, the handheld device to be able to see underground utilities. Well, GPR, if you don't know what's underground, is a great technology to use to explore that. And so what that does is it shoots radar waves into the ground as it runs over. You see kind of a picture of it's almost like a very high-tech push vacuum cleaner there that would run over a surface and capture the rebound waves from the radar. And if you have the right calibration and the right visualizations, you'll be able to identify whether you might be seeing like steel on a bridge deck or any underground utility. You'd be able to see the depth underground that utility is. And so it can be a technology you can use to create the models that would drive that AR data. So there is some significant hardware investments with that, and a lot of the hardware vendors will have proprietary software to use their data. But again, the DOT, that's archival information that they'll want to know so that they can figure out, or they can know what's below their the ground there. And so having a way to store that data is important. Since the vendors provide their specialized access software, a lot of DOTs weren't too concerned with security. They would store that information in Bentley's ProjectWise, which is kind of a project administration software system, so that again, it can be tied to a specific project and archived for the DOT's use at a later date. Workflows, it typically will be wrapped into different DOT surveying practices. So that's with appropriate training, it integrates pretty well into what the DOT is often doing. But it was noted for this one in particular, we talked to Oregon, Florida, and Michigan, and Oregon in particular mentioned their big challenge is using the data in the office, transferring it, sharing it, things like that. Training is still often vendor supported. There's some DOTs that have developed technical and hands-on training, but the big thing is the calibration to the material that you are moving that GPR equipment over, and then how do you interpret the data? So you'll see, radar waves. So how do you know whether you're seeing a pipe or just hitting rock, below grade? Again, this is something that would need confidence with both internal and external stakeholders to demonstrate its value. So doing pilot projects and outreach through different presentations, webinars, things like that can be helpful to get support. And I mentioned the processing of the data can be time consuming, might require some manual data work as well. So there's computer skills, computing hardware needs that need to be considered. But anything that you can do to help validate results and build confidence in, again, a new technology is beneficial. Oregon did a kind of a cost and time savings analysis with identifying subsurface conditions. And so typically if you didn't have this non-destructive GPR equipment that you just run over the surface, you might have to core the materials. So they produced a significant cost savings as well as a time savings by using the GPR equipment. That's something that they reported out last year. So those were 3 of the 10 technologies that we looked at. Some feedback from the interviews that we conducted with the DOTs. There's a lot more with this project that is ongoing that we've completed as well that I haven't shared, but we're running up against our hours. So with that, hopefully there's some helpful information there in theory, in practice, and as well as in applications here. So that's all we had.